So what we're focusing on is an operator collecting data in the field through sampling, in this case, a manual sampling process, where they are checking, does actual equal expected, right? Now, expected is a range of numbers we've given it to be in, right? And actual is what they're going to the field and measuring. Now, the part about it, though, is for us to know whether that is in spec or out of spec takes a human to take those two values and, like Clark brought up, contextualize it. Understand not only is it inside those boundaries, but has it changed drastically over a set period of time? Do we see a trend appearing? That's from that manual data that we usually enter and look at as if it was the matrix streaming numbers down where we pick out patterns. And that's how we've had to do it with paper in the past. The nice part is once you digitize that, you get much more context and richness in it that allows the human brain to really see pattern recognition much easier. And we'll look at that with the demo. But the other part about it is we don't want to just look at it for pretty pictures. We want to look at it because we're collecting these numbers, because if these numbers are not within this band, we want somebody to take an action. Now, this is a list of instructions, which based on which plant you're in may look really familiar or may look super advanced or way not advanced at all. And that's really where we are in our operations and that maturity, right? Do we have a sticky note next to the computer SCADA screen, or do we have pages and pages of SOPs? The answer is it doesn't matter, right? Because each step of what we're supposed to do is based on an analysis of some kind of value. What we've done in the past, unfortunately, is we've made our people the analysis point. That worked great when we used to spend a ton of time training those individuals and we had a bunch of institutional knowledge. The issue is now, as the workforce is changing, we're bringing new individuals in, we don't have time for them to do 30 years in the job to get to that level of knowledge. What we need to do is take that level of knowledge that we know is out there in the operations in the floor and build bumper lanes for new operators. Now, will it mean that they can operate like a 40-year operator right off the bat? Of course not. Not going to happen. You need that knowledge. You need to be in the field. You need to be doing the operations. However, we can do a little life hack and maybe steal the first 2 or 3 steps of let's keep you in a safe place. Because right now, if you notice, we're talking about treatment goals. What is the impact if we don't get this right? Okay, well, we may overdose or underdose the water, which is a cost based on chemical feed. Fair enough. Well, we may not dose this correctly, and then we can't send that water downstream because it doesn't meet the requirements of a regulatory agency. Ooh, now we're talking some impact. In a chemical organization where you're now mixing chemicals, if you don't get these things right, there may be unintended consequences that can cause damage and pain and agitation within a system that can really hurt people and potentially kill them. So when we're talking about maintaining a system in control and returning it to control, it is ultimately about safety. Once you have a safe, controllable system, then you can do the optimization on that. And that's really what we want to do here, is get it into a safe, controllable solution. So assuming we give this to an operator, we now say, hey, go out to the floor and we're going to have you take some logs. Now, the 2 tools I'm going to use for that, one is called OpsTrakker, and we have multiple modules within